Okay, towards the latter part of the other video when we were talking about num tests, I've added a call out to the value in the variable. I'm going to try to do that throughout this program to help you keep track of what values are in these different variables because it's important to always, when you're looking at the variable, realize the variable is not the variable, it is the value contained in the variable. And so when you can't really follow the logic unless the variable has a value, because you don't know how the logic evaluates until you give it a value. So one of the important parts of debugging is to always mentally, either for declared, like constants or whatever that already have a value, you have that to refer to. But if it's based off of user input, then you need to pretend that the user put in something in particular. That's very important also in going through these debugging assignments. So we looked at, the user's going to get output. They're going to be asked to enter student name or ZZZZ to quit. So I say, sorry, there's 5 Z's in it, but this quit, we're concatenating again. We've talked about this before, but we're concatenating the value again, because this is a variable, a constant, the value of this string into the with these other two literals, with this literal in front of it and this literal after it. So the user is going to see enter student name or ZZZZZ to quit. They're going to type something. Before we jump down here and assume, okay, well, they type something, always understand this, we're assigning a new value to the variable called name. That's the first thing that has to happen. So now whatever the user typed is in this variable. Now earlier I talked about variables being uninitialized. They're declared but not initialized until you assign a value, and you can't really do anything with them until you do assign a value. That's partially true. You can't ask for a value, you can't compare, you can't do math, there's a lot of things you can't do. What you can do is assign it a value. So even though we look at this, we say input name, you can kind of think of it as, well, kind of as reverse of this. Again, I don't want to throw you off by typing something else here, but think of it as like whatever the user input, we'll just call this user input. We're assigning this to this variable called name. So it's no different than if we actually straight up assign something over here, but we're doing that on this line. Whenever we see that input, and we'll get back to how it was there, that's what we're doing. So there's no bug with that. Now the users type something. We're going to pretend that they typed Bob. So name is Bob. Actually, I'm going to go back on that, because just to follow the first shortest path, we're going to pretend they actually did type the string to quit. They typed this. They typed ZZZZZ. So if they typed that, how does this evaluate? That's the question you have to ask yourself. This is the not equal operator. It's going to look more familiar to you possibly like this, for those of you that paid attention in algebra. The exclamation equals, actually it's the equals the line through it in a book, but if you have to type it out, it's exclamation equals. So anyway, that's what that is. In this book they use this convention. Less than, greater than, together means not equal to. So we're saying name not equal to quit. Every question, every loop control question or if statement or whatever always comes out true or false. Nothing else, no other way to evaluate it. True or false? False. So the question is this true? Well, obviously this value, ZZZZZ, is in fact equal to this string quit. So not equal is false. It's kind of a double negative going on there, but that's how we have to get this, because in order to exit the loop, you have to evaluate false. So if we wrote it the other way around, it would just be wrong. So that is correct. It does, then we go to the end of the end while, we stop the program. Good. Our code looks to be correct. That's the only way in which it does that. If it's a value, if anything else is in name, like Bob, like I said, or anything else that the user might type, this not equal to ZZZZZ is going to evaluate true. Does So as long as it evaluates true, we go on. Another principle to remember when we're looking at debugging, we do not change things unless we have a reason to change them. I think that's something I should have highlighted on at the beginning, and I will probably do that in the future, but there are things that you're not going to understand right away. You're not necessarily going to see immediately why we assign 0 to total right here, but that doesn't make it wrong, and I apologize, that just popped up. There we go. It's not wrong until you determine that it causes a bug, basically, I guess is what I'm trying to say, unless there's something wrong with the syntax. So, okay, we're assigning 0 to total. We're initializing that variable. Good deal. Next line. Now we know that total is 0. So next line, we want to determine whether sub, this variable called sub, which we declared up here, whether it is less than num_test, which again is 4. Well, what is sub equal to? Right now, it is garbage. The only thing we've done is declare it. We have not initialized it. We haven't done anything with it. So you might be thinking, okay, well, what do I do then? Well, you initialize it, obviously. Quite a few people might think, oh, well, I'll just go up here and put 0 in there. Well, that would not be correct either. But for the sake of argument, I'm going to go ahead and let it go at this for the moment. And we're going to prove why that's incorrect. So, because for our purposes, that does solve our problem right now. Sub, when we get to this point, the first time we open the program, now has a value of 0. So we will go ahead and say that 0 is less than 4. So we execute the body of the loop. We know that we have 4 test scores to enter, so we're asked to enter a score for the first test. We're going to again put that value in. That's going to get assigned to score. Score has not been initialized, but we are now essentially initializing it, so that's fine. We'll just say that they got 80 on this first test. So we're going to take total. Now, we had initialized total. Well, let's look at this side first. We initialized total, so total is 0. So that's good, because if we hadn't done that, we couldn't do math with it. We couldn't do this part. So now you know why we did this. Because you can't take garbage and add a number to it and wind up with a number. You would wind up with garbage. So 0 plus 80 equals 80. So that's what the new value of total is. We've executed the body of the loop, so we hit the front side of the end while, which means we go back up here. We ask it again. Well, now what is sub equal to? If you answered 1, you were incorrect. We did not change the value of sub whatsoever. Sub is still 0. There's another bug. This is an endless loop. Sub did not increment. Now this is one of those places where I see a lot of people make a mistake because they know what the program's supposed to do, but it didn't do it. That's what we're here to find out. So we're going to take sub and do sub plus 1, just like we do down here. There's an example of it. That's another thing. There's often examples elsewhere in the program of how to do it properly. So, alright. So now, if we go through that first time, now sub becomes 1 at the end. 1 is still less than 4. So therefore, we enter the second score. And we're going to say that he got, I don't know, 70 on the second score. And so we're going to take 80 plus 70 and assign a new value of 150 to total. And then sub was equal to 1. We're going to add 1. Sub is now 2. And we go back up here and ask the question again. 2 is still less than 4. We enter the body of the loop for a third time. Enter the third score. We'll say that he got 80 again. So now we have 230. Well, I say 230 because 150 plus 80 is 230. Jumped ahead of myself there. Well, sub was equal to 2. Last we left it. So now we want to add one more. It's going to be equal to 3. 3 is still less than 4. So that's good. We entered the loop for the fourth time. We enter the fourth score. Just to make it a nice even number, we'll add another 70. And that gives us 230 plus 70 is 300. So sub is equal to 3. It now gets added one more, now becomes 4. So now we go back up here again. You might say, well, we're done. Well, we're not done. We don't know if we're done, that is, because we can't just end. We have to go back up here and ask this question. Now, is 4 less than 4? No, it's not. So you're right. We do skip the body and we go to the next line of code. However, if this had been coded to say less than or equal to, that would be a bug. That's why you always have to follow the logic where the logic goes, not where you think it's supposed to go. We'll go back here, and I'm probably going to sound like a broken record on that, and I'm sorry, but it's just really important. Average. Okay, we have a variable called average up here. We did a variable check on it. That's good. Total. We have a value for total. It's 300 divided by num. What is num? If you said, I don't know, that would be fair. It does not exist anywhere. It has not been declared. Num in the lowercase form is just the type of variable that we refer to throughout. What we want to do, obviously, if you know how to calculate an average, is divide it by the number of tests. So we have a variable for that. It's called num underscore tests. So let's use that. That is another bug. So total 300 divided by 4 is going to leave us with 75 for the average. I'm going to go ahead and break this up again. This is going to be part 2, and we'll pick up from here and go on. Thank you.